Welcome to Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker, and welcome to this fragment. Okay, so today we're going to talk about item number 7 in Joshua Bloch's Effective Java book. Again, we're reading the second edition of this book. For the listeners who are just joining, if you're not familiar with what we're doing, we are going through the Effective Java book written by Joshua Bloch and covering each of the items inside of the book, which basically teaches us a whole bunch of good stuff about what to do or what's recommended in Java programming. So follow along. These fragmented episodes will typically be anywhere from 5 to 10 minutes long, and we are trying to push them out a little bit faster every week at this point in time. So today we're going to be talking about avoiding finalizers. Now, Joshua Bloch says that finalizers are unpredictable, often dangerous, and generally unnecessary. Now, what he basically means by this is that they can cause erratic behavior, poor performance, portability problems, and so forth. Now, they do have a few valid use cases, which we'll touch on here again in a second. The thing with finalizers that usually get people kind of stuck is a lot of C++ programmers are usually trained to think that finalizers are Java's analog of C++ destructors. And in C++, for the C++ folks out there, C++ destructors are the normal way to basically reclaim resources with an associated object. It's a necessary counterpart to the constructors. Now, in Java, we have the garbage collector. And the garbage collector reclaims the storage associated with an object when it becomes unreachable. So it's basically this non-deterministic little beast that kind of runs around and cleans up all the garbage and collects it. So we really don't need any extra effort on the Java side to perform any cleanup. Now, in C++, the destructors are also used to reclaim other non-memory resources, which, in C++ you can do a whole bunch of stuff, but the destructors are very important in C++. Now, in Java, we have a different construct that we can use to always make sure that we're cleaning up valuable resources, such as like files and so forth, and that's usually going to be the try finally block, and we'll talk about that here in a little bit. Now, one of the big problems with finalizers and why there's a big issue with it inside of Java is that there's no real guarantee that they'll be executed promptly. It can take quite a while for these finalizers to be executed. And during that time, the object could be unreachable for a foreseeable amount of time. So we could have this memory just kind of hanging around. And as we know in Android, memory's limited. We're on an embedded device, basically. We don't have that much memory to work with in the first place. So we want to make sure we're cleaning up things as fast as possible. And if we're relying on a finalizer, and a finalizers are basically can take a long time to close, that can be a problem. So we never want to do anything that's time critical in a finalizer. And as Joshua states here, it's basically a grave error to depend on a finalizer to close files because open file descriptors are a limited resource. So we could, for some reason, get the JVM to basically blow up because we have all these file descriptors that are open in that use case. So that is a big reason. Furthermore, the promptness of when a finalizer is run is basically dependent upon the JVM. And there are a lot of implementations of the JVM out there, and the implementation of when finalizers are run varies wildly from JVM to JVM implementation. Now, in Android, we're working with a particular version of the JVM, so there's not a ton of things we have to worry about, but still, we'll get more to the Android stuff here in a minute, but it's something that we don't have to worry about as much, but typical Java programmers do. Now, because the finalizer is non-deterministic, we're not sure when it's going to run. If we leave all of our object cleanups to happen inside of the finalizer, we could essentially run out of memory because a lot of this stuff's just kind of hanging out, and we're waiting for the JVM to hop in. There's actually no guaranteed call to say, hey, why don't you run this finalizer? And that becomes a problem here. And so what that means is if we can't be guaranteed that something's going to get called on time, we never want to depend on a finalizer to update critical persistent state. So, for example, depending on the finalizer to release a persistent lock, maybe on some type of resource such as a database, would kind of be a good way to bring like a big distributed system to a halt because we're not sure if it would ever be released or when it would be released and so forth. Now, don't be tempted to use methods like System.gc and System.runFinalization. I actually fell into this trap early on in my Android development career. I was working with a lot of bitmaps, trying to do bitmap modifications and camera applications. and was running out of memory a lot. And so I started forcing the System.gc, and sometimes it would work, sometimes it wouldn't. For the longest time, I couldn't figure out what it was. And then eventually, a couple years actually, I figured out what was happening behind the scenes. These methods simply increase the odds that the finalizers are going to get executed, but they don't guarantee it. The only methods that claim to guarantee finalization are System.runFinalizersOnExit, and of course, as Joshua states here, it's evil twin Runtime.runFinalizersOnExit. Now, these methods are basically flawed and they have been deprecated, so basically step back and avoid these if possible. Now, if you're not 100% convinced that these finalizers should be avoided, here's a little tidbit for you. If an uncaught exception is thrown during finalization, the exception is ignored and the object finalization terminates. So this means that uncaught exceptions can leave objects in like a corrupted state. And if another thread tries to access this object, it could be get some behavior that you're definitely not expecting here. Print some stack traces out, thread could blow up, all kinds of just different junk could possibly happen. Finally, there's a severe performance penalty for using finalizers. Now, again, this depends on the JVM and the machine and so forth, but any type of performance penalty in Java is something we need to be worried about. If you've watched any of the dev bites from Google where they talk about all the different tricks about how to improve performance, enums matter. Whoops. So what should we do instead of writing a finalizer? Or what should we do if we do need to provide a finalizer for any particular reason? We need to provide an explicit termination method. And so the best way to think of this is like a close method. And now common examples of this are going to be like the input stream, output stream, SQL connections, timer has a cancel method, stuff like that. So you need an explicit call to say, hey, I need you to close this. I need you to cancel this. And the best way that you're normally going to do that is with a try finally construct. And that ensures that you can actually close this. So you're going to wrap, maybe you're going to open a file inside of the try block and you do some work in there. You do the catch to catch any exceptions you may run into on accident. And then in the finally block, you make sure that you close that resource that you're using. So if anything goes wrong during the execution of the try block, the finally block will take over at the end and say, all right, I'm going to go ahead and clean up all my resources. So that's usually the best case. That's probably what you're going to see used most of the time in Android. And that's typically what I'm going to be recommending to most developers that I see out there. Now, if you are using Java 7, there is something that you might be interested in, and that's the try with resources. So take a look at that in the Java docs. It's basically a way to enforce that something is going to be cleaned up, but you have to use auto-closeable with that, the auto-closeable interface. So just take a look at that. We'll put this in the show notes, the try with resources and the auto-closeable. You can take a look at that. Now, a lot of developers don't use Java 7 still, unfortunately, and we would like to use even Java 8 or better, but this is the world that we live in. So now, when are finalizers good, and when should we probably use them? Now, Joshua states there are two probably use cases where we're going to use these. One is to act as a safety net in case the owner of an object forgets to call an explicit termination method. Something needs to happen, so you can kind of check to see if maybe something has not been closed. You can do that inside of the finalizer. Now, again, there's performance penalties for that you need to be aware of. But Joshua does state that the finalizer should log a warning if it finds that a resource has not been terminated or cleaned up or so forth. Now, he does cite a couple of examples of the explicit termination method he's talking about. And those are that's going to be the file input stream, file output stream, timer, and a connection, and so forth. And they have finalizers that serve as safety nets, as he calls them. And what they do is they get called in case the termination methods aren't called in general. Now, the second legitimate use case of finalizers is going to be with native peers. And a native peer is a object or native object to which normal objects delegate via native methods. Now, it's not a normal object because the garbage collector doesn't know about it because it's not even on the JVM. It's down at some native layer. The JVM really doesn't know that it needs to clean it up. And so the finalizer would be an appropriate place to go ahead, clean up things to make sure that there's no critical resources that are kind of left hanging. So again, that's going to be your job if you're dealing with a lot of native stuff, is to make sure that you are closing those connections to any native resources that the JVM may not know about as well. Now, there is an important note here that finalizer chaining is not performed automatically. What that means is if you have object A and object B and B extends object A, if you forget to call super.finalize in object B, which is the child object, you forget to call super.finalize, which calls the A class, its finalizer, there is no guarantee that will get executed at all. So if you have a bunch of resources that are left lying around, you could technically kind of create some memory leaks and so forth. Joshua goes into a little bit more detail about some topic called finalizer guardians and making sure that enclosing classes can kind of clean up after themselves. I'm not going to dive too deep into this because at this point we're kind of just beating a dead horse. In Android, we really don't follow some of these patterns of having to clean up with finalizers and so forth. You rarely ever see it in any samples out there. Normally inside of Android, we're going to follow the activity and fragment lifecycle or services, etc. And we're going to clean up a lot of our stuff inside of the onDestroy method or the onStop or the onPause, depending upon if you need something in the UI to be visible, you may do that in the onPause or the onStop. Now, if it's something that can live long term until the activity or fragment's destroyed, you may decide to clean it up in the onDestroy method. And so we're not really going to worry too much about how and when to use these finalizers. Now, again, the exception is if you are working with native code, you kind of need to make sure that you're cleaning it up. Okay, well, that pretty much wraps it up for this Fragment episode. We will see you next time.